Hello everybody to our today's presentation of our Spike system and of what we've developed new. At first, we are a German company. We are in Kaufbeuren, and we got two kind of strategics. We got at the one side we got our temperature control. You can see on the oval level, and in the middle you can see tool control. And today I want to talk about tool control. Sensors for process monitoring. There are a lot of different kinds of sensors in a machine. For example, on the right side you can see we got force measurements like the power, the spindle power, or vibration sensors, which are not new. We got two different kinds of sensors which we produce. One is Spike Mobile, which is the holder version. We got on our tool holder different sensitivity classes, and we got a spindle integrated, in the spindle nose integrated spindle sensor, which, for example, you could buy from DMG or Grope. What is the difference between the sensors? There are different kinds of signals you will get, for example, torque, axial force, bending moment. But so far it doesn't matter which kind of signal you get. The thing is, you want a signal which you could monitor, which gives you the right signal for your process, for your quality estimate. So we can, with our new data hub, which we've developed, we can now combine all these signals. So we have an open source software where you also can, via RP or all other signals, you can send us the signals and we can put it into our new software. Our Spike and Spindle is not just for monitoring of the process. We also got a chip and spindle detection. So you can detect a chip on the plan surface from about 10 micro or at the cone from about 30 micro without any time delays during your machining runtime. We also can measure the pull-in force of your tool. And also, because we are now at the spindle nose, you can monitor, you can detect your spindle, because we now know the bending moment and the axial forces of your tool and of the spindle. And for process monitoring, we got our Spike Mobile, so the decision, you can even retrofit with the Spike holder. The Spike and Spindle, you need to install a new spindle into your machine, which is very expensive. But with the Spike tool holder, you can also retrofit all your machines. I've explained the chip detection, so I don't want to go that much in detail. And most of the follows you even know. Today, I want to talk more about process monitoring. So how to detect tool breakage. Sometimes you just want to know yes or no. But for toolware, you don't even just need to know if it's yes or no. You want a reaction, maybe change sister tool. That's something we do in our process monitoring. Drilling deflection during your drilling process is something you don't realize with torsion moment or axial force. With our bending moment, we see during the drilling operation if there's a deflection or not. A single cutting state. So with our patented Spike Polar, we'll go on it on the next slide, you can even see every single cutting fluid, and so can react on a single cutting edge breakage. And with our sensors, we can also detect vibrations or chatter marks. Strategically, we get a patented single Spike Polar, which allows us, out of the bending moment, to detect each single cutting fluid. So when our tool is turning, we are located on a tool holder, a spindle nose, so we are turning in the same speed like the tool. And that's the reason why our coordinate system turns with the same RPM than the tool. And that's the reason why we can detect every single cutting edge. It doesn't matter at which RPM the tool is turning. And so we can detect the force on each cutting fluid, and that will help us to make out of big data, we can do smart data. So with filter algorithm, and we can reduce the points. With other algorithm, we can make even one single number out of a big information. So we can tell you, and that's called our spike Kpis. So we can call symmetrical. How symmetrical is your tool cutting? That's a number between 0 and 100. And also, like I've said before, for chattering, we can tell you, okay, you're chattering at a level of 0 or you're chattering at a level of 100. So we give you one information which now is possible to make a reaction or a decision at the machine. At this example, we see a diameter 6 tool, and you even can see how sensitive our signal is. Even this small cutting edge damage has a huge impact on fluid number 1, which is monitored. And you can also see that then afterwards, tool number 2 has a lot more work to do, and so the force on on fluid number 2 is increasing. But the newest development of PRO-MICRON is now the machine communication, that our system is could be completely integrated into your machine. And there we combine our spike measurement data with the access data and a lot more information out of your machine. And that's the reason why we could build our spike map, which is the digital twin of your producing tool. So at a demo on our DMU from DNG at our technical center in Kaufbeuren, we did an aerospace part, which could be seen here. So what happens if you get no sensors during your process which couldn't see the forces, what's going on? So you have a static tool life. You can say, okay, I got 500 parts or 200 parts or minutes. You have a multiple set of efforts. You get a high downstreaming quality costs, and you have a late defect detection. With our sensor, we can now inline measure. So there's a solution which is called Spike Map. With our Spike Map, we have, for example, our sensory tool holder, our Spike Mobile, and with our Spike Mobile, we now see that is what we do in real time. That's not afterwards. That's not a recording. That's how our system works in real time. So we get the X data and the X information out of the machine, calculate a 3D and the tool center point, and we put there the information of our sensors. And so we can, for example, see here at this aerospace space part at the Blisk, we can see the phenomenon of chattering exactly located where it is. So you can do also afterwards a lot of analysis, a lot of detail. You can combine parts, but that is one of the things which gives you a new platform of data, which will you allow to do a lot of analysis and quality measurement during the process. We also have now new in our technology center, we got a grope machine, and on our grope machine, for example, we have a lot of other partners which came to us and asked us for help in their processes. For molding and for mold making, we did another analysis with our Spike Map. So live in process quality report. On the quality report, I will go afterwards. So again, you are machining, and sometimes just with the ball millers, just with this small AP and AE, you will not get that much information out of your spindle engine and of your spindle torque. But with our sensors now, you can see at the bottom of the screen how high the forces are, how clear the forces are, and that's how we can, again, in real time, build this digital twin of the tool. And even now, in real time, we can do reactions, like change sister tool, stop, and what we even actually can't do, but we want to do in future, even maybe adaptive feed rate or something like this. But that's project, that's not what is normal for us. So afterwards, analysis, there were some problems you can see directly on our digital twin. Benefits of our spike map. And there's a huge cost factor afterwards. So in the quality documentation, in the afterwards, after machining quality report. So we have now an inline surface quality control. We have an inline process monitoring of sporadic and systematic errors. We can do machine reaction, for example, change sister tool or machine stop. And we have a documentation via quality reports, like you can see in the middle. So every single part which is produced, you can now get the information. The highest force was at that level. Your chattering KPI was at level 0, or the highest time it was at level 30. So you can document every part you produce, and now afterwards put it in your storage, or for example send it to the customers which takes your parts. We have a display, we have connection of Spike and also to your data lake if you want to, so we can send the data via API, via Data Hub or Profibus, Profinet or whatever to your device, and you can go on with our data. So messages to remember. We got new sensors, but you don't need the sensors if you don't want to. But if the spindle torque isn't sensitive enough for you, we are here on booth number A21, so right around the corner. So if you get time afterwards, don't hesitate. Come to our booth, ask us questions if you don't want it here. We got our patented Spike Polar, which can detect every single cutting fluid. We can detect vibrations, tool breakage, or other things. We have our Spike Kpis, so low-level data low-level, smart data, not big data, not even big data, and we got our digital twin with quality reports.